This is Jerry. His eyes can only see so far upwards and so far downwards. This is called his field of view. When Jerry looks at an object, the imaginary line between his eye and the object is called his line of sight. When Jerry looks across a level plane, anything remaining equal height across the ground, this is called his eye level. This is Jerry's house. On the door, there's a peephole. This peephole is at Jerry's eye level. And if you move the house across the plane to any distance, that peephole will always remain at his eye level. When Jerry looks at his house when it is close, it takes up a large portion of his field of view. That's called the object's angular size. If we move his house away, the house takes up less of his field of view, and its angular size is smaller. But the peephole remains at his eye level. But to Jerry, it looks like his house got bigger and smaller as it got closer and further away. But really, the only thing that changed is its angular size, taking up more or less of his field of view. Let's do some more perspective demonstrations. For that, we'll need some help from Jerry's friends. This is Natty, and this is Tony. The top of Natty's head is right at Jerry's eye level, but Tony is a bit smaller, so Jerry can see Natty's head with no problem. In Jerry's field of view though, Tony does block a part of his view. In this moment, Tony is an obstruction, and Jerry can only see Natty's head because Tony is in the way. And Natty's head is also an obstruction. And if we bring back Jerry's house, the bottom of the house is obstructed because of Natty's head. It is at Jerry's eye level. But no matter how far you move away Jerry's house, the top portion will always be visible because it is higher than Natty's head. But now let's take Jerry, Natty, and Tony off the flat plane and put them on a curved surface. Now Jerry has to look a little bit down to see Natty and Tony, and just for a second, we don't need Tony in this demonstration. Right now, Jerry can see all of Natty, because Natty is standing on Jerry's visual horizon. The horizon is the last part of a curved surface that you can see. But beyond the horizon, Jerry can't see, because the surface he is standing on is curved, and beyond the horizon is blocked. Now if Natty moves to a further position, then he will start to disappear from the bottom up. Now if we put Tony back in, Tony is still shorter than Jerry and Natty, but because of the curved surface, now Tony blocks Jerry's view of Natty. Now if Jerry moved to a higher position, then his line of sight is raised, and the horizon moves further away. Now Jerry can see over the obstructing surface to see more of Natty. It's pretty simple. But wait! Jerry has one last question. If the surface he is standing on is curved, then why does he not see the curve? Well, that one's pretty easy. It has to do with the distance of the horizon. If you are standing on a curved surface, the horizon is a certain distance away from you and at a certain angle in your line of sight. Any direction you look, the horizon is at the same distance at that same angle, so it won't look like it's curving. Another reason you don't see that surface curving, since the horizon is close to you, even though you can see really far, the horizon is the last bit of surface that you see, and the portion itself is rather short in length. It only represents a small portion of that surface, so its curvature is basically unnoticeable.
Oh my god!